So today we are graphing in the form, the learning target. We're adding on, this looks similar to what we did on Friday. On Friday we just did ax squared, now we're doing plus a c term in the back, which is going to be a transformation of our graph. And I'll show you that after we do the first example. All of our steps though are staying the same. We still have those 3 steps where our first one is to make a table of our values. It's an XY table that has our X's are our inputs, our Y's are our outputs. We make a table, we plot the ordered pairs, and an ordered pair we get from making our point from our X's and our Y's. And then we draw a smooth curve through the points. And the shape that we make, the math term for it, is a parabola. And our parabola can look one of 2 ways. It can look like a U, or it can be a upside down U, depending on what transformations are happening within the graph. So let's start with just the first example, and we'll take us through all the same steps that we did on Friday. We're going to start by making our table, X and Y. And we're going to keep using these same points until I tell you otherwise. We're using -2, -1, 0, 1, and 2. We have to now go through our steps, plug all of our inputs in, and these are our inputs. When we plug them in, we get outputs. So, we'll go through and do some calculations. We're going to plug in -2. So say y is equal to -2 squared minus 2. And again, when you're squaring a negative number, if you're not doing it in your head, you're doing it on a calculator, you need your parentheses around it. So this is a need for sure. So -2 squared is a +4. And then we take +4, we subtract 2 off of it, so you get back to 2. So that is our output for an input of -2. We do the same thing, but now we're plugging in -1 for x. So again, we're plugging in negative numbers, so I need my parentheses around it. -1 squared minus 2. That's 1 minus 2. That's -1. This is going in our table. We now plug in 0. 0 squared minus 2. We know 0 squared is just 0. So we take 2 away from 0. -2. Let's do the last 2. Let's plug in 1, then we'll plug in 2. Y is equal to 1 squared minus 2. So that's 1 minus 2, which is equal to -1. And y is equal to 2 squared minus 2. So that's equal to 4 minus 2, which is equal to 2. So we have -1 and 2 for the rest of our table. So before we graph this, yeah. Not yet. So before we graph, remember that just like our graph, our table is symmetrical as well. So whatever goes in this spot is going to go in there as well. Whatever is up here will go down there as well. So the next examples, I won't go through and do all 5 of these. I'll only do 3 of them and just fill in the blanks. So now I can graph, and I'm just going to go down my table and graph each point. Negative 2, 2, that means I'm going to the left 2, then up 2. Left 2, up 2. Negative 1, that means I'm going to the left 1, down 1. 0, negative 2, I'm just going straight down from the origin, going down 2. Then 1, negative 1, I'm going to the right 1, down 1. Then here I'm going to the right 2, up 2. And your last step, draw a smooth curve through all of them. One thing I will say, your curve doesn't have to be perfect. You don't want it to look like a V though. You should be able to see that there's a curve at the bottom. You also don't want it to look like this. That's not good either. These two are no good. You want it to be a U shape. What I'm going to do quickly is Friday we talked all about the parent function, y is equal to x squared. And I'm going to graph that as well on here in red. Just doing it quickly, I know that it's going to be centered at the origin. It's symmetrical, so now it'll look like this. So this black graph and the red graph are similar, but they're not lined up correctly. It looks like we went from the red graph and we shifted down 2. And that's what, you see this minus 2 on the back, we would call that a vertical shift. So if you're ever adding a constant at the back, it'll shift upwards. If you're ever subtracting a number, it'll shift down. That's why the black one is lower than our parent function, because we had a shift down of 2 units. From our origin of our parent function, this value is just shifted down 2 units. From this point, it's just shifted down 2 units. From this point, it's just shifted down 2 units. So it's the same parent graph, we just have a transformation. All right, example 2. We have 2 things going on here. We're going to have a vertical shift of 3, and this negative in the front, so a negative 1, is going to flip our graph upside down. So this should look like a frowny face when we're done graphing it. We're making the same table that we have been. Now we just have to be careful with this negative when we're figuring out our output values. So we're plugging in y is equal to, make sure that negative's in front. And then we're only plugging in the numbers for x, and that's the only thing we're squaring. So in parentheses, I should write negative 2 squared. And then it's plus 3. So then I'm going to go through and simplify. Negative 2 squared is 4, but I still have that negative in the front. So then it's a minus 4 plus 3, which is then equal to negative 1. So I know that goes in my table. I have to now plug in negative 1. Y is equal to negative 1 squared plus 3. So that's negative 1 plus 3 equal to 2. And then I got to plug in 0. 0 is an easy one to plug in. Y is equal to negative 0 squared plus 3. Well, 0 squared is 0, and 0 can be neither positive nor negative. So we'll just write it as 0 plus 3 is equal to 3. And here I don't have to find the other 2 because I know it's going to be symmetrical. I know this value is going to be the same as that value, so is this one. So we can fill in the rest of our table with 2 and -1. Now we go and we take this, our symmetrical table, and make a symmetrical graph using our points. All these are x comma y points. So our first point that we're plotting is -2, -1. So you go over 2, down 1. Our next one, -1, 2. So we go over 1 to the left, up 2. Our next point is 0, 3. So we have to go up 3 units. 1, 2. It's symmetrical now. So if you really stink at drawing parabolas right now, I promise it gets easier the more you do it. You want to get as close as possible your line going through all 3 of your points. So you can see how if we were to flip this and then shift it down, we get back to our parent function where it's centered at the origin, just going up normally. So we'd call this a flip and a shift. You'll talk a lot more about transformations. Gosh, not even geometry. In Algebra 2, you talk about it more. We're going to do one more example together. We'll do example 3. So this is your time. If you have questions or you want me to check something, I can check it as you go. Our focus for this problem should just be on making sure that we're following our order of operations correctly. So we're saying we're plugging in a -2, so I'm going to write that all out. Y is equal to 1/2 times -2 squared plus 2. We have to make sure that we're following our order of operations, or PEMDAS, where we have to do any exponents first, then multiplication, then addition. So we have to do our -2 squared to begin with. So -2 squared is 4. So we have 1/2 times 4 plus 2. Well, 1/2 times 4 is 2. Then we have 2 plus 2. That's equal to 4. So that goes in our table. So our next step, we have y is equal to 1/2 times, now we're squaring -1, plus 2. So this is 1/2 times -1 squared is 1. Then we're adding 2. So 1/2 times 1 is 1/2, or you may write it as 0.5, because probably graphing decimals is better than graphing fractions. So this will be 0.5 plus 2 is then 2.5. The last one you have to do is just 0 so you can get your vertex. Why I've been having us do it -2 to +2 is because each time our 0 point is our vertex. Tomorrow that'll change. Right? Tomorrow we're going to have more flexibility on what we put in our table. Not a lot of flexibility, but it'll be different. So our last piece, we have to figure out what our y coordinate is for our vertex. Say y is equal to 1/2 times 0 squared plus 2. So that's 1/2 times 0 plus 2. So it's 0 plus 2, which is equal to 2. So this is 2. We use the fact that it's symmetrical to say this is 2.5, this is 4. So your final graph will look like this. -2, 4, we're going to the left 2, up 4. We're going to the left 1, up 2.5. So go up 2 boxes, halfway up the third. And our vertex is at 0, 2. So 0, we're just going up 2. And then it should just be mirrored along the other side. 1, 2.5. That's right here. 2, 4 is right here. So we have two things happening. Our graph was shifted up 2 units from our origin. And it also was, we call it an expansion. When you have a number in front of your A, so back here, this is where your shift is happening. Shift, you're right, you're shifting up 2. This tells you where we call it an expand or a shrink. If this number, it's our A value, is less than 1, we're expanding. So our U is getting wider. If your A value is greater than 1, it's getting narrower. So it's going if you even look at your homework from Friday, you can see how some of them are wide, some are narrow. It's all dependent on whatever number is out in front. So that's our focus for today. What we're going to do tomorrow is we're going to add a term in the middle, a B term, and we'll graph that. It'll be a whole new process. Similar, but it'll be a new first step. So you have 8 problems to do for homework. You have plenty of time to do it, so make sure, I want everyone to be able to get this done. So make sure you're focused and working. If that is not the case, we will find a way to make you focused. Sweet. Let me pause my recording and let's get it.